Time is the apparent progression of events from the past to the future. While it is impossible to fully define the nature of time, we all share many common time-related experiences. Causes naturally lead to effects. We remember the past but not the future, and the evolution of time seems to be continuous and irreversible. Time seems more confusing than space. The question of how many seconds per second time flows or one moves through it is obviously absurd because it suggests that flow or progress involves a rate of change relative to something else, some kind of hypertime. But if this hypertime itself is flowing, then a hypertime is required, and so on forever. Again, given that the world is thought to span space and time, it may be asked whether human consciousness moves in a temporal direction of this world, and if so, how quickly does it emerge as future events reach them now, or has it been there all along? How such changes in spacetime can be represented? Ordinary change, of course, can be represented in a picture of spacetime. For example, a stationary particle is represented by a straight line, and an oscillating particle by a wavy line. So then, is time relative? Einstein's special theory of relativity, which we will explore further, revealed that the experience of the flow of time is relative to the observer and their situation. Previously, Isaac Newton's work assumed the existence of a master clock that kept time synchronized throughout the universe. This clock was not thought to actually exist, but the concept allowed Newton's equations to work. However, building on his previous work, Einstein discovered that the flow of time is relative. In special relativity, moving clocks run slowly. The faster you move in space, the slower you move in time. This effect increases as you approach the speed of light. In the decades since Einstein first proposed the concept, physicists have made numerous measurements that demonstrate this effect. The atomic clock on a jet plane runs slower than on the ground. A subatomic particle called a muon does not exist long enough to descend from the atmosphere where it was formed when cosmic rays hit air molecules. But since muons move at close to the speed of light, they seem to exist longer from our perspective, allowing them to complete their journey. When Einstein developed his general theory of relativity, he extended this concept, known as time dilation, to situations involving gravity. The presence of strong gravity also slows the passage of time, so a clock in a strong gravity well will run slower than a clock in mid-space, for example, on the Earth's surface or near a black hole. Another question is, can they be time reverse? Almost all the laws and equations that physicists use to understand the natural world are symmetrical in time. This means they can be reversed without changing any results. For example, if you watched a video of a ball rising into the air and falling again without any other context, you wouldn't be able to tell whether the video was playing forward or backward. However, there is one aspect of physics that seems to respect the flow of time, the concept of entropy, which is a measure of disorder in a system. According to the second law of thermodynamics, entropy always rises in a closed system, and this evolution cannot be reversed. However, there is one aspect of physics that seems to respect the flow of time. Physicists do not know whether the increase in entropy caused the arrow of time or whether it was just a coincidence. Finally, does time really exist? Scientists, philosophers, and others ponder the nature of time. And although we've learned a lot about time, such as the fact of time dilation and the possible connection between time and entropy, we haven't been able to find an exact definition of time. Some philosophers and physicists have argued that what we experience as time is just an illusion, an artifact of our consciousness. According to this view, the passage of time is not real. The past and the future already exist in all their dimensions, likewise the whole of space exists. According to physicist Sean Carroll, what we perceive as the flow of time is a byproduct of the way our brains work when processing sensory information from our environment. Against the universe, people's time is limited, so let's be careful to spend our time on more accurate things. Don't forget to like and follow. See you in the next video. Bye.